Hello, this is Miss Cliffner with your video lesson for today. It is lesson 5.2a. It's the first homework that we're having in this new section on Big Ideas Math, and it's all about using ratio tables to find equivalent ratios. So here's the warm-up. I'm just going to show it to you and skip this part for the video just to get right to the video. These problems are from the homework on Monday. Okay, so here's our lesson, right? Fill in the information. Two ratios that describe the same relationship are equivalent ratios. They might not have the same numbers, but they're equal to each other the same way that fractions can be equivalent. So you look for multiplication and or division patterns to see if ratios are equal. You can find and organize equivalent ratios in a ratio table. So that's the idea of today. You're seriously, if you don't know your multiplication facts, you're going to need to get out a multiplication chart so that those numbers will come to you. We're looking for patterns of multiplication or patterns of division. All right, so here we go. So let's say you've got an example where for every one pen, you've got 3 pencils, right? So here's a pen, and you've got 3 pencils. But then somebody comes along and says, well, wait a minute, what if I have 2 pens, right? So now I have 2 pens. If I want to keep the same ratio, I also have to add in 3 pencils. And altogether now, I have 2 pens and I have 6 pencils, right? So you can see from the picture what it looks like. And here's the math I'm doing. I look at when I'm trying to fill out information that's missing from the pencil row, I look at the pen row to give me the pattern. When I went from 1 to 2 pens, it was a times 2 pattern. So I also have to times by 2 to figure out how many pencils I would need to keep the same ratio. Now for the next example, I'm going to use a different color. And this time the number of pens is missing, but I know I have 9 pencils. So when I go from 3 to 9, it's a times 3 pattern. And when I go from 1 to blank, I have to use that same multiplication pattern times 3. It's like multiplying by a giant 1. So here's what we have. We have 1 pen to 3 pencils, or 2 pens to 6 pencils, or 3 pens to 9 pencils. And I'm going to go ahead and, didn't mean to do that. I'm going to go ahead and drag 1 more pen over, so it's going to match. And when I drag 3 more pencils over, you can see that now I have 9. So the idea is if you keep the ratio the same, the numbers have to increase with a multiplicative factor. Okay, let's look at another example. If we have dogs, so here is our 4 dogs. And for every 4 dogs, let's say at a kennel, they have 6 cats. And so now what happens when I try to figure out, well, if they had 12 cats, how many dogs would they have? So I go and I know what I'm doing is multiplying by 2 because now I'm having 12 cats. So I also multiply the dogs by 2. So now I have 8 dogs. So when it says show your swoops, here's what I'm talking about. To find the pattern of a missing number, I go to where the numbers aren't missing. From 6 to 12, it's times 2. So then I also have to multiply the 4 times 2 to get 8. So now on this one, when I have a missing number of cats, I don't know how many cats, but I have 24 dogs, right? So right now I have 4, 8, 12, 16, 20, 24. I have 24 dogs. You know there's going to be more cats, right? So what did I multiply the dogs by? So I have 1, 2, 3, 4, 5, 6 sets of 24. So I'm going to use a different color, right? When I go from 4, when I go from 4, let's move that back down where it was, 4 to 24, it's multiplying dogs by 6. So that's a swoop. And then I also go back to the original cat number of 6 and I swoop. And if I multiply 6 times 6, I get 36. So when I say show your swoops, what you have to do is you have to start and end. You have to start at the same number column and end at the same number column and do the same multiplication to both the top and the bottom number, like when you create equivalent fractions. Okay, So here's an OYO, so go ahead and pause the video and try these two on your own. I'm going to start with this missing piece of information, so I need to go to the bananas. For every 4 plantains, there's 3 bananas. If I multiply 3 times 2, I get 6. So I have to multiply 4 times 2 to get 8. Now, this time the bananas is missing, so I need to go from 4 to 12. Now, the reason I didn't go from 8 to 12 is because there's not an easy number to multiply 8 by to get to 12. But there is a whole number. 4 times 3 is 12. So then I multiply this number times 3 to get 9. So I'm basically creating equivalent ratios. All right, so let's do this in blue. No, I want to, yeah. I'll do this one in blue. To find out how many euros to dollars, if I don't know the dollars, I have to look at the euros. This would be times 2. So 4 times 2 is 8. And then in the second row, I'm missing the euros. If I had dollars, now this time I've got a choice. I could go from 4 to 32, which is times 8, or I could go from 8 to 32, which is times 4. I'm going to choose the times 4 because it's easier for me. Times 4 is 40. But I'm going to show you, you would get the same answer if you did times 8. 4 times 8 is 32, and 5 times 8 is 40. Okay, next, now we've got a ratio table that's all blank. Notice I'm going to read the instructions and circle the important numbers. You're making sugar water for your hummingbird feeder. A website says you should use 4 parts of water for every 1 part sugar. Okay, now it says you use 20 cups of water. 20 cups of water. How much sugar do you need? So what do we know before starting? We know it's 4 parts to 1 part. It doesn't matter if the parts are teaspoons or tablespoons, as long as we keep the same ratio, we're going to be okay in terms of the mixture that we're making. So what I'm going to do is I'm going to put water here, and I'm going to put sugar here, because those are the 2 things that I'm mixing. Now, notice they give it in cups, so I'm going to go ahead and write cups at the end just to keep an idea of the units that I'm using. So water is 4 cups of water. That means I would use 1 cup of sugar. Now, what I know is that you're going to use 20 cups of water. So when I go to fill in the 20 on my table, I leave a bunch of blanks because I might need to put in middle numbers. But what I'm going to do is at the end here, I want to use 20 cups of water. And then this is the information that I'm trying to figure out. How many cups of sugar goes with 20 cups of water? Now I can do some skip counting, right? I could do, this would be 8, this would be 2. If I double the 8, I get 16, and this is 4. You can see I'm getting there little by little, but it kind of makes sense to just jump across the whole table. If I go from 4 to 20, it's a times 5 pattern. So I do the same thing from 1 to the blank number of cups, multiply by 5. So I'm calling these swoops. So all in one swoop, I can get from 4 to 20, which means it's 1 times 5, which is 5 cups. It's not a bad idea to go and take some small swoops, right? Every time I go from one column to the other, I'm considering it a swoop. So what I figured out was I need 5 cups of sugar. I need 5 cups of sugar. Okay, so we can fill out the middle columns, but if we can just, if there's an easy whole number, even if it's a decimal number to multiply by, we can skip all of the columns in between and just go to the final column. All right, so here is an OYO. Same idea, you're making, this time it says a sweeter mixture of sugar water, and this time you are using 3 parts, where's my red? 3 parts of water for every 1 part of sugar. You use 9 quarts of water. So here's what I'm going to do. I'm going to put, this is my water. Oh, let me put that in blue. Okay, this is my water. This is my sugar. And now I'm putting 3 parts of water and 1 part of sugar. But now it told me the measurement is in quarts. So I'm going to put quarts here. QT PTS. Okay, this time I have the amount of water as 9 quarts. So the thing that I'm trying to figure out is how much sugar now do I need. Remember, I can fill in the middle rows, or I can just swoop to the end. Is there a number that you can multiply 3 by to get 9? Yes, there is. It's times 3. So if I triple the water, I need to triple the sugar, and I get 3 quarts of sugar. That's what I need. I need 3 quarts sugar. All right. Last idea, using a ratio table. Hey, here's some nutrition information, right? Let's say you're trying to limit the amount of salt in your diet. And so it says that if you look at crackers, there's 240 milligrams of sodium in every 36 crackers. So I'm going to label sodium and how many crackers I eat. And notice the sodium is in milligrams. So I just go ahead and put milligrams at the end of my table. There's no reason to make the table messy with units because I know what they are now. Oops, I can spell crackers. The crackers is just the number, right? Okay, so now I need to put in 240 milligrams per 36 crackers. And now my final thing is this. You're going to eat 15 crackers. How much sodium? So I put the 15 down there in the row with the crackers, and this is unknown. I don't know how much sodium is in 15 crackers. Now, if I could easily go from 36 to 15, I would, but I can't. So what I'm thinking about is I'm trying to think about a number that I could put here that would make this swoop easier. And so I start to think about the factors of 15, and 3 and 5 come to mind. So I'm thinking if this number was a 3 or a 5, there would be a nice easy number to multiply by. So what I'm going to do is I'm going to also use other factors that I know. And I'm going to think about 36. 5 is not a factor, but 3 is. So I found a common factor between the 36 and the 15, and it is 3. So here's what I'm going to do. I'm going to divide. So this is the first time we've divided. I'm going to erase my swoop. Let's erase that. Okay, so oops, that's not an eraser. There we go. Okay, so now I am going to, when I go from 36, I'm going to divide by 12 because I found a common factor of 3. And 36 divided by 12 is 3. And 240, this gets a little bit harder, right, divided by 12. Oh, and of course, the number that I'm going to divide both of these by has to go evenly into both of them. Okay, so I got a 20. And now what I need to do is I need to swoop a second time, but this time I'm going from 3 to 15 and 20 to the end. So 3 times 5, right? I was thinking about two numbers that I multiply together to get 15. And then I would multiply the 20 times 5, and I get 100. So sometimes you have to play around with common factors. And I'll show you another way in the coming days about how to figure out some numbers in the middle of your table. Okay, so you consume 100 milligrams of sodium. All right, last OYO. So this is on your own. You're mixing 3 pints of yellow for every 4 pints of blue to make a green. Circling 3 pints yellow, 4 pints blue. You use 10 pints of blue. Okay, so I'm mixing yellow and I'm mixing blue, and they're both in pints. So I'm just going to put pints, oops, PTS for pints. Okay, yellow is 3 and blue is 4. Now, let's see. I need to fill in 10 pints of blue, so here is my 10. And that means what's missing is how much yellow do I make, because, oh my gosh, I need to have a total here. So I'm going to write this at the bottom because I looked at the question and it says, how much green paint did you make? I already know it's more than 10 because there's 10 pints of blue. Now I need to figure out what ratio of yellow goes in, and then I have to add those up. Okay, so I'm thinking of the number 10, and it has 2 and 5 as factors. And I know that 4 also has 2 as a factor. So that's my common factor. Even though 3 is not divisible by 2, I'm not going to let it bother me. I'm going to show you what to do to make a decimal. Okay, so if I swoop once and I divide by 2, I get 2. Now when I divide 3 by 2, it's a little bit awkward, right? It's not a whole number, but it's 1.5. So that's not too bad. And then when I go and I swoop again, when I go from 2 to 10, it's times 5. So 1.5 times 5. And that's the decimal number, and I get 7.5. Now I'm going to add the 2 to get a total, and my total is 17.5. So I made 17.5 pints of green paint altogether. Okay, good luck with the homework.